since, we are under military rule, yeah, I will try to be as brief and crisp as possible. We'll leave that 5 minutes. I think you should ring the bell, else, I think since morning, I generally when you are called, you try to reach 1 hour before, and after the session just leave. That's the kind of thing that generally happens. But in this particular case, when I read the names of speakers who are going to speak in the inaugural session, I decided to come 1 day earlier. It's always inspirational to listen to people whom you listen to, and I think you will agree with me. Rajendra has been an old friend, and he's been into policy making. Many times we forget about policy making at the macro level, and he generally brings it out very succinctly. Dr. Devi Shetty always, is an inspirational talker. He always has taken cudgels for the medical fraternity. There are very few who generally do that. So taking that and, also taking the advantage of Rajendra's presence here, which a lot of policies which get made, but very few get made, for infrastructure, and I was just talking to Mr. Swaminathan in the tea break, and brick and mortar was what he was wondering whether, India can build that kind of a thing, especially in the tier 2, tier 3 rural, kind of area. So what I'm going to present to you is a journey which I have followed myself over past 18 years of consulting practice in healthcare industry. I am a medical doctor. I have nothing to do with architecture or construction, but on the way, we learned it because we realized that, we need to do it for our own sake. Okay, that if we want good hospitals, we want, good operation theaters, patient safety, then we need to get into it ourselves. And there are many here who have taught me, this field, Colonel Matwankar, Colonel Verma, many of them from whom I have learned. So let me now begin. What I'm going to, talk to you about, how do you approach hospital planning, and then you leave it to, your architect to do that. What is efficient planning? The definition that you are seeing might sound very simplistic to you, right? Doing right things right the first time. But mind you, ladies and gentlemen, the doing right things itself is a decision that you make, and that decision better be good. All right? So if you are deciding that you make a 50-bedder or a 20-bedder, that decision should be right in the long run. Okay? Having decided what you want to do it, you do it right in first shot, and that's what quality is all about. Otherwise, the rework that costs you is phenomenally high. The building that you are going to build is going to stay there with you for 40 years at least. That's the amortization, as per the income tax law also. That's the life of a building. So what you are doing, you need to, do it right the first time. Remember that you are investing for the next 40 years, like I said. There were, earlier no standards for hospital engineering, which has now become easier with NABH. You still have to, maybe walk more on that path. But now at least there are certain mandatory norms, because earlier there was nothing like a 400 square feet, operation theater, and, there was no minimum height for the flooring to ceiling. Nothing was given. So you were just left. I was in Raipur, just 2 days before, I think on Wednesday. It's a big city. It's not a small city, but the type of hospitals which I visited, could have been better because they didn't know about the norms. Medical tourism is lot been talked about it, but I don't think you can match up with the standards, which the other countries have. All right, we are still having this voluntary kind of thing. We have a practice in Middle East. We have an office in Dubai, and there, it's mandatory for you to follow the JCI guidelines. We still don't have mandatory. So it's left to us, that what norms we are going to follow. NABH is a good norm. I think you could begin with something like that. I'm going to talk about something others also. Hospital building is highly engineered, and as doctors, especially for entrepreneurs who are into smaller towns, our own knowledge about this building engineering is poor. Let me tell you that. It's poor. We do not know that how much money goes into building. So suppose if you have a 100 rupee project, you are going to spend 60 rupees in this building, of which you have very little knowledge. Okay, you may still know something about the design, but you won't know much about the engineering systems. More than 50% of cost, like I've said, is in the building, and 50% of that is in MEP, which stands for mechanical, electrical, and plumbing. This is alien to doctors and people who are not from civil construction background. Most decisions that you will take will end up as irreversible, So once you make a column and the building stands on it. You can't do anything about it later. So if you go for a leased premise, which is what many of these young, new centers are doing, then you need to see whether your height is enough or not. Okay, so those kinds of things. More technology advances, and I think a colleague of mine is going to speak on that. So, and it has interplay of agencies from diverse, fields. The steps, basically I would follow 5 steps. Project conceptualization, that means you need to understand what you want, so the size, the facility mix, number of theaters, numbers of outpatient clinics, phasing of growth, because many times that affect, future kind of planning. For example, you say that I want a 200 bed hospital wanting to go to 300, then you need a water tank today for 300 beds, because you can't create an underground water tank later. You need to size some of this engineering, today itself. Having decided the project concept, you go to the next step, which is financial viability modeling, something which, doctors are poor at. So you need to look at it very carefully, and you should do a what-if analysis, in the sense, what happens if, your project goes down by occupancy, or, the interest cost goes up, or time duration, only then you launch into a project. Otherwise, you get stuck midway, and there have been examples in this city as well. Third comes the building design, which I'm going to talk. Project management is the fourth one, because having designed the building, you need to roll out in a defined time span, which also doesn't happen. There are umpteen number of examples for that. And the last step is commissioning, where you set up systems, policies, procedures, IT infrastructure, and everything else. Now look at that, you have at least 11 people that you need to interact with. And you ask yourself how much of it in terms of the subject knowledge which is rolled out, the architect, structural, HVAC, engineering, electrical, blah, blah. I'm not going to talk about this. I'm not going to, this is a little bit, where we go wrong normally. So just, mull over it. This deriving the realistic project cost itself is a big problem most of the times. We always want to hear that a building can be built in 2,500 or 3,000 rupees a square foot. In city of Bangalore, you perhaps will not be able to build a corporate sector hospital less than 3,500 rupees a square foot, which is quite large sum of money. Okay, so if you venture into with a under-capitalized project, you are going to be in trouble. So please understand that well, means of finance, income, expense, all that actually helps you to take the go and no-go decision. Now coming to the architectural briefing. The first thing that we do is functional programming, followed by space program, a typical need identification, and I'm going to talk about that in the following slide. So what do you mean by functional space programming? So what we do is we break down the hospital into departments, okay, and we say that this is, I think, for non-invasive cardiology diagnostics. So we say what is the activity that we are going to do here. So what, whether you want to include certain other things into this or not, you want to do Holter monitoring, yes or no, number of 2D echoes, number of stress tests, all of that, operational assumptions, which would say that timing, report shall be, from where, so everything is documented down, okay. So for this, you perhaps will need to interface with the user if your subject knowledge is not good, and then project a workload for which you will rely on the financial model that you prepared, because that projected workload will help you to design the department optimally, okay. Otherwise, you will have crowded waiting spaces, no toilet areas, smaller rooms, all that will start to happen, all right. Then comes the functional relationships. So there are certain things which will be written down there, that certain departments need to be closer. So say if CSSD's proximity to operation theaters, or a surgical intensive care's proximity, or a pharmacy and say sample collection, to be in vicinity of outpatient clinics. So things like that get written down. So this is what the briefing document that the architect actually is looking for, okay, because he, mind you, doesn't know hospital as you and me does, okay. So that this is what comes out of a functional program, which then gets converted into a space program, which means that you start putting numbers in square footage to the rooms. So suppose if it was non-invasive cardiology, so you will say reception, waiting area, and you will start putting a net area column to that, and and then grossing factor, which is for circulation area. So this needs to be done for every department, okay, basis of which you actually know how much square foot, because the first thing everyone asks, how much square foot per bed is required for a hospital. So that may range. For a government hospital or a charitable trust hospital, or the hospital I visited in Raipur day before was something like 350 square feet per bed, all right? Whereas some of the Indraprasth Apollos or Columbia Asias would be closer to 800 to 1000 square feet a bed. That's kind of disparity which exists, all right? So if you do this space program, you understand what kind of area one is looking at building. The next step after you do a departmental space programming is to do a stacking. Okay, stacking means you know that how much is going to be your area and how many floors. So you start putting from the space program departments on floors. So you have a limited area, 10,000 square feet say per floor. So you try and see what departments aggregate to 10,000 and you batch them up. You understood? With the functional adjacencies. It's not that easy, but you can do that. It's not very difficult either. Note down certain typical need identifications, say the heights, which is one of the major problems, in hospital planning, especially for operation theaters, MRIs, linear accelerators, cath labs, you need higher heights. So go with a 13 feet or a 14 feet height for at least these departments, if not all the other floors. Civil engineering, there are many different requirements. A linear accelerator needs a 6 feet thick concrete wall all around it, so it will need maybe a 6 meter height. So all these things need to come out upfront and be told to the architect who is planning. Third is a concept called service floor, which is sort of a sandwich floor, with a height which is not more than 2.1 to 2.4 meters, because you cannot use it for anything else except engineering. And generally, this floor is sandwiched between the operation, it's on top of the operation theater floor and below the inpatient floors. So every engineering that happens on this floor. So all plumbing will come down up to this floor from inpatient toilets and then get distributed outside the building. All air handling units of the operation theaters will be on this service floor, okay? And mind you, every theater needs a separate air handling unit nowadays. Air quality requirements, if you don't know, there are standards which are available off the web. Width of corridors, major problem, till, I think NABH came up and said that you need 8 feet minimum, 2,400, mm minimum. Many nursing homes find that difficult to do that. Toilet for handicapped is now become, I think, mandatory, one on each floor. Residential accommodation, if you need vertical transport needs, nowadays people want bed to go into a elevator, not only that narrow stretcher, because you then don't move the patient 4 times over, bed to stretcher, stretcher to bed. Then environmental needs, whatever are there. So am I done with 15 minutes?
3 minutes more.
Pardon? 5 minutes more. So I'm not going to touch on this. I'm just going to talk about a grid matrix. This is the key actually for hospitals. What is the key? The grid of the column in which you are going to fit in a room. This is one of the most important decisions you take in a hospital design. A good grid is given there, 6.5 into 7.5 for a teaching hospital, 7.5 or 8 in a private kind of a hospital. Now this will decide the size of your rooms in future, all right? And this, if you go with a 8 by 8 meter grid, you can also accommodate 3 cars in the basement. If you go by a grid which is less than 7.5, between 2 columns you can park only 2 cars. Decisions are made on things like these. You and me don't know about that, right? But an 8 by 8 meter is an optimal grid to follow. This is how that grid plays out, so it is accommodating a 6 bed ward, it is accommodating a twin room, single room, you can also take an operation theater, because an 8 by 8 is a 640 grid, so an operation theater fits in quite well in that. So it should be flexible. The grid, whatever you decide, needs to be flexible enough. There are other considerations in terms of cost, but what important is the flexibility in the design matrix per se. So this is just an example of how grids are used. This is something, which you have to take a call, whether you want toilets which are towards the corridor like in a hotel, all right, or you want a toilet which are toward the window, so that plumbing becomes easier. You are just out of the building and the sewer line just goes down. Okay, but if you do that, if you will see, the window is compromised, because half the window is hidden by the toilet. In the earlier example, it was not so. You get the full window. So that's a decision that you need to take. There is also a mid-board toilet. We have used it in some of NHS uses it, quite well, because it gives you a full, bed, in a good size. I think Seven Hills Hospital in Bombay has done something similar. Now the next thing is the engineering design brief and a room data preparation. What actually is room data is, that you have one room, so it's an outpatient clinic. So you put everything in that outpatient clinic in a room data sheet. So you say, I need 4 plug points, I need 1 wash basin, I need medical gas, I need 1 fan, I need blah blah, whatever. And you number that room and put it. You do that for the 1,000 rooms that you are going to have, it becomes very easy for the engineering consultant then to design for your needs. Otherwise, it's a mayhem. Because he is doing things that he wants, you are thinking he is going to accommodate whatever you want, it doesn't happen. Okay? So if you do things in a systematic manner, it will be good for you. The other thing, is very quickly, there are 3 things in electrical, HVAC and plumbing. So you need to calculate the load, okay, properly. Otherwise you can undersize at times, majorly. What goes on UPS, what goes on generator, you need to tell, you just make Excel spreadsheets. Very easy to do that. Young MHA graduate can also could do that. Imaging equipment draws huge amount of power, so you need to understand that. There are identification of nodes and voice. There's been a lot talked about today about information technology. You have lux level requirements which you need to understand. And there are, if you look at the bottom part of it, there are electrical standards which are available off the web. So it's not that it's not available, it's just that we don't go and look at it. That's a problem. The rest of it, you look at the budget, it would be anywhere between 200 to maybe nowadays 500 rupees a square foot. Okay. There's another thing that you need to keep in mind. It costs money to build a hospital. Okay. That's why private sector doesn't go into tier 2 and tier 3 towns. HVAC design, whether you want a fully air conditioned hospital, yes or no. Okay. It starts from as basic as that, and as Rajendra was saying in the morning, the government is also, we did a hospital, Ram Manohar Lohia Hospital in Delhi. It's a centrally air conditioned emergency trauma center, 80,000 square feet, centrally AC. Never ever was done before. Okay, so they are also moving in that direction. There are some heat load calculations, there are zoning that needs to be done. So what operates for 12 hours, what operates for 24 hours, you segregate that so that, adjacency of departments also becomes easy. Then comes the tonnage, and for that, remember, it's not very intelligent always to put this glass facade in front of your building. If ever you do that, you use a glass, which is double glazed, so that it cuts the heat and allows the light to come inside. Otherwise, don't use too much of glass. It's not very good for especially north and central India, where heat is, you approximately require 1 ton of air conditioning for 200 square feet. That's the rule of thumb. And you look at the budget, it's 80,000 to 1 lakh per ton. So it's not small either. Okay? It would culminate into maybe 350 to 400 rupees a square foot. Your knowledge and my knowledge is poor as far as air conditioning systems go. You could also do some life cycle costing, as I have mentioned the second last part of it. All right, so I'm done. I am done, sir. So I'm just going to roll through. This is the service floor which was there. Yeah, this is what I was saying, that if you look at that building in Nagpur, there is no glass, 48 degrees temperature. Okay, the one which you see is Asian Art Hospital in Bombay, which has little glass because 38-degree peak temperature. All right, I think I should say thank you and just go back to my seat. All right, it's my email ID. In case anyone wants to interact with me, most welcome. Thank you so much.
Good afternoon, everybody. Mr. Chairperson, Mr. Co-Chairperson, my colleagues on the dais, ladies, gentlemen, students. Since 20 minutes is going to be a very short time, I'll start off. The theme of the conference is safe and sustainable hospitals. And the answer to this, the whole concept of this conference can be actually through this case study. You know, it can be actually compressed and said, yes, if you study this hospital, it covers everything, because this hospital is NABH and LEED certified platinum rated hospital. So let's start. It's a green hospital, and green means basically LEED certified, and LEED stands for Leadership in Energy and Environmental Design. This is basically a suite of standards made by Green Building Council of the US, and now it has been adopted by our country. And the bottom line is environmental sustainable construction. Any green hospital is environmental sustainable construction. So basically, LEED was created for propagating green buildings, which also includes hospital. And the idea is basically to reduce our carbon footprint on Mother Earth. That's the whole idea. And our hospital industry, the industry which guzzles the maximum number of energy, 24 into 7 into 365 days energy consumption. So that also gets reduced. So very, very advantageous for the hospital industry. So what is a LEED rating system? LEED rating system basically addresses the 6 major areas. Sustainable sites, basically I'm going to talk about greenfield projects. Sustainable sites, water efficiency, energy and atmosphere, materials and resources, indoor environmental quality, innovation and design process. So you see, the whole concept of your conference today is covered in all these 6 major areas: sustainable and safe. So let's start with sustainable sites. I'm going to talk very at the basic level, because I'm seeing a lot of students also sitting in heaven there and a lot of students sitting at the back side. Of course, the veterans are here, but it's this mainly for students, for you to understand. So I'll come to your level. I'll not talk very technical for you to understand. So I'm not going to go into technical terms. When we talk about this area, you can score possibly 13 points, and our hospital achieved 10. So in this, if you see, there are a lot of activities at the beginning with the site selection to the construction process to after construction. So it's got different, for example, during construction site, what is the transportation that using? What is the site selection? Site selection, is it near a public transport system? Is it in a community? And so on and so forth. So because of the time constraint, I'm going to rush through. So let's see how we achieve those 10 points. Everybody knows what is stormwater management. Stormwater is rainwater and rainwater harvesting. That is what we did. So we have 3 ring wells and holding tank capacity of 87 KLD. And if you see on the right side, you see those pavers, you see green grass in it. Okay, so water can be actually collected from that. So it serves 2 purposes: harvesting, as well as later on it also I will talk about heat island effect. So basically it is also there to control the heat island effect. So temperature control also. And of course it is for water harvesting too. So quality and quantity both. It's not only quantity. Quality, if you see the mesh system over there, you remove all the suspended solids from the rainwater. Heat island effect, roof and non-roof. Basically, what you are trying to say is, on the roof, we see that heat is reflected, so that your hospital requires less energy to cool down the hospital, so less utilization of electricity for HVAC systems. And in the vicinity, in the perimeter, we have on one side I have shown you those green pavers, and also the other pavers which will reflect heat. Okay, so basically it is both. And on the roof, if you see on the right hand side, there is a roof garden. So roof garden also helps to reflect the heat. Especially in countries like ours where a lot of heat is there, definitely helps. So we achieved 80.33% of high SRI roof area. So this is basically solar reflective intensity. Basically, don't go into the technical part of it. The idea is how you reflect heat. Here you can see the glass pavers, one more point, the native plantation. We actually have native plantation, that means local plants, so that you don't require a lot of water and energy to look after it. Energy in the sense, physical energy, but water, you conserve on water because it's local plantation. Coming to the next is water efficiency. Here we talk about how you control water, how you save water in terms of landscaping, in terms of potability, in terms of wastewater, in terms of HVAC. So all that is covered in this. And we achieved all 6 points in this. So we have a modern sewage treatment plant. So we treat all the sewage. And this water, recycled water, is used for flushing, it is used for irrigation, and also for the HVAC cooling towers. We already talked about rainwater harvesting. And we also use plumbing, where, for example, you have shown that shower. Generally, a shower will come with force and loss of water. But in this case, the water used is at a very low flow rate. Similarly, we have automatic sensors for urinals and WCs. And as I talked about, native plantation. Here we achieved 41.3 reduction in the water usage. Coming to energy and atmosphere. This talks about, we achieved 13 points out of the 17 points, and here we basically talk about the energy and the atmosphere, internal as well as external both. So in this, what are the, we have used CFC reduction in HVAC, how we have used it, how we have used optimized energy usage, green power, ozone depletion, all these points are covered in this. And we achieved a saving of 40%. You see, in optimization of energy performance, we gained 9 points. So it's basically, in this area, it's basically a comprehensive approach. So how we have shading devices and orientation, how we optimize energy performance, what is fenestration strategy in the windows, then how do you have a comfortable indoor climate, not very hot, not very cool, and you save on the load, electricity on the mechanical devices like the HVAC, because air conditioned hospital is running 24 hours, a lot of energy. So it's basically an integrated environmental benign building. This is for architects and engineers. I won't go into this. The idea of this slide is just to show you how we have used those double glass windows, so that heat which is kept outside is kept outside, and in winter, heat which is supposed to be, in the internal atmosphere, how you can conserve your energy, your coolness inside the building. So it is basically how you keep your heat outside. You see the brick walls. Even the brick walls, they have got four layers, and how we keep out there's a special material used, and how we keep the heat outside. Recessed window is basically punched out windows. I will show you a photograph. How that also helps to save on energy, so that less of heat will come out and less of heat through sunlight will come out. So you see those recessed windows? That is the architects in this audience will understand it much better. Even the roof, if you see, there are 4 layers, and here also we have used special material. And over and above that, that is to reflect the heat again. And over and above, we have a rooftop garden with local vegetation. How we have used the modern R134A, that is the latest coolant, state-of-art HVAC, metering equipment for data analysis, because you have to keep on analyzing your data, otherwise you may feel that you are saving energy, but you may not. The best part is, I don't have geysers in my hospital. 84% of hot water is generated by solar energy. At the rooftop, I have got solar panels. And my group also, the Kohinoor group also has got windmills. So we generate energy and supply it to the government. And we get a sort of a trade-off to use that in our hospital. So we use wind energy, we use solar energy. Then how do you have optimal lighting? So wherever you require lighting for work, there is work areas lighting, then there is wherever you don't require, there is co-lighting. Then for example, in public toilets, generally what happens is people use and the lights are on. But in our case, if there is no movement, then sensors will say, sense there's no movement, automatically the light is shut off when there is no usage of the public toilets. So overall we achieved, this is again technical, forget about it. See, this is an actual picture of co-lighting, actual picture of task lighting. Then what are the green features? Quickly we'll go through. We have water-cooled screw chillers. The other technical things are meant for architects and engineers. For students, I'm just telling you what are the green features. Then low water loss, because the cooling towers are very modern, so very low water loss. Then the pumping system of the HVAC, as the cooling increases, the pump will go at a lower rate. If the heat is increased, the pump will be a little fast. So there is variable volume in the pumping system. Then variable frequency drive. Again, it is to do with the same concept. The very good concept over here is the CO2 sensors. Now suppose we are sitting in the conference hall of this building, and suppose this hospital is a green building. So many of us exhaling carbon dioxide, automatically more fresh air will be pumped in. If we all go out, less carbon dioxide, automatically less fresh air is pumped in. So this is what we have developed the concept in our hospital. Carbon sensors, CO2 sensors. Then both the heat recovery system for inlet and outlet, both. So there again we save on, and of course this is independent systems for independent rooms, VAV systems. Again technical, but not to worry. So overall we achieved a load of, HVAC load of 1 TR, tonnage that is, for 500 square feet. For a conventional building it is a little on the higher side. So 500 square feet is better than the ASHRAE standards. ASHRAE standards are the United States standards. This is again savings, how we have calculated. Now we come to the indoor environmental quality. This is also part of, as I was saying in my earlier opening statement, that safety for the patient, safety for the employees, both. So indoor quality of air. Here we achieved 12 points after 15. And here, what are the things that we have done? So a lot of things during the construction phase, construction material that is used, so low emitting materials. Then how have you controlled the thermal, as I said, not very hot, not very cold, and how we have used daylight. So of course, no smoking, so naturally, I mean, this is compulsory now. Filters are used for, this is again technical, so don't have to. CO2 sensors, I was talking about this, increases your fresh air. Then this is how the fresh air, 30% increase in fresh air delivery. Then temperature, the spaces are designed in such a way that it is 23 degrees, optimal for the human body. Then I was talking about temperature sensors for both return and air ducts. Then humidity we have to maintain, so not to exceed 60%. So this is how the indoor quality is maintained. Then we have in the construction phase, we have used low emitting substances, so adhesives, sealants, paints, the carbon, the carpets, wood and other products, everything has been used, it is low emitting. Then controllability of lighting and thermal comfort, we just talked about it. Every room also individually, for example, consulting rooms, they have individual systems to control somebody may want it a little hot, somebody may want it a little cool, something of that sort. So this again is a little technical. Provision of skylight, I have 5 minutes, sir. Yeah. So provision of skylight, so we take the natural sunlight in areas, and I talked about fenestration strategy of the windows. I'll just show you photographs. You can see this. On the right hand side, we have used the natural sunlight, and the picture on the left is the main lobby of the hospital. See all the rooms, actual pictures, best use of sunlight. The material and resources, here also we achieved 8 points, and here also how we have reused our construction waste and construction material. We have the waste material is used for the landfill, then factory-made furniture, and for glass for the windows, etc., etc. Again, less of wastage. We have used recycled steel. I'll show you a picture. So we had a factory over there earlier. You must have heard about the famous Premier car, the Premier car. Earlier, when Maruti was not introduced, we had only Ambassador and Premier car. So the factory of Premier automobiles was there, and we bought over the factory, and we have reused all that. So metal was used from there. Reuses. So local harvested material, certified wood. Innovation and design, in this we got, we achieved 5 points. And in this, again, how we use the design, how it is innovative, and of course, the building was designed by lead accredited professionals. So there also we earned a few points. So reduction in water, waste management of construction, regional material used, recycled material used. Overall, sustainable overview of the hospital. So you see, whatever I talked in one slide, just how the future of hospitals, future of sustainable hospitals is a green building, a green hospital. I'll just show you the lead score, how we earned. Maximum we could earn 69. We got 54 points. So that is why we are platinum rated, and we are the. This is where we people talk that green hospitals are costly. So I just wanted to prove a point to you. These are the incremental cost increased by, if you see the conventional building, only 3% more. Out of the, we spent 60 crores, only 3% over a conventional building. And see the energy saving, 40%. This is the certificate, how it looks. See on the right hand side, the solar panels I was talking about, and the left hand side, the roof garden. I think I am done, sir. Thank you. This is, this is the photograph of the recycled metal we use for our overhead tanks. And you see in this picture on the right hand side, we store the heated water. And you see the material that is used on the tanks. So what happens, even if you don't have sunlight for some time, still the water remains hot. So these are the few pictures I just wanted to. So thank you very much for your patient hearing.
Good afternoon, everybody. I think my colleagues before me have pretty much taken a piece of my pie, I would say. They've both discussed pretty much what I do for a living. I'm a pure architect. We run an architectural engineering firm, and that's what I focus on it. As Dr. Vivek said, they learned the architecture because that's the need for hospital operators and doctors to understand hospital design. We cannot become doctors for sure as architects, but we still try to understand the mindset of a doctor and try to design a hospital from an operational perspective rather than my architectural egoistic approach. You know, architects have huge egos usually. So we try to understand the hospital approach, and that's how I've been practicing doing a healthcare architecture for the last 18 years or so. So I'm going to pretty much talk about the major points and maybe describe them a little more. What are the basic parameters? I think Dr. Vivek has already explained a few of those. I'm going to have a repeat of that a little bit. You start from outside in. I mean, this is a big box is your hospital. Let's assume that. Major access points to the hospital. Where do you penetrate the hospital? Major entry, main entrance, emergency entrance, service entrance for loading dock. I mean, if I take that, these are the three penetrations to the hospital, majority, and emergency for sure, there's an emergency. If you take care of that business in the design, that's the first fundamental. Interdepartmental adjacencies. What belongs next to each other? I mean, it's a simple thing, you know. If you actually walk a hospital as a consumer, as a patient, you can understand that emergency needs to have diagnostics next to it because you need to have a probably CT scan done after an emergency episode or something. And emergency needs to be close to an OT suite because you may need to go to OT suite from that. That's the basic adjacency concept. So as an architect, when we understand all those adjacency concepts, you know, our planning becomes much, much easier to do that. Access control. This is a huge subject in healthcare all over the world, access control. Outpatient patient should not even perceive the hospital beyond outpatient department and diagnostic and pharmacy. He should think that the hospital ends here. He should have no visual, no communication to other things. So he has a very contained access control where he is. An inpatient, he has to have access control for more than that space. Back of the house, it's only for the support and the doctors. Nobody should know there's a back of the house. So that design philosophy has to be taken care in the design process. IP and OP segregation, I think all of these comes to that. And inpatient and outpatient should not mingle. That is the basic philosophy I've learned from doctors only. I'm not, as I said, IP, OP mixing is not, it's a no-no. If I can use loose English there, it's a no-no. That's the approach we all want to take. Not that we succeed all the time, but if you take as a basis of design, your project is already very successful. If you actually can do that due diligence to start of the design, your project is actually way ahead in thinking, then you can actually everything. Wayfinding. For a patient, I need to have a very, very easy wayfinding philosophy, purely from a layout of the hospital or from other features in the hospital. Let's say there are multiple vertical lift cores to go somewhere. Interior design with color coding should suggest certain things, so I move that way. So interior design philosophy and actually laying out the building in a certain way should help wayfinding, because hospital is a complicated building. It is a very complicated building. If I let somebody in and say, just find me that room, he can take half a day to find that room. It's a possibility. So wayfinding for an outpatient especially should be very, very well handled in design philosophy. The next point I'm writing is departmental segregation with respect to operational hours, which has been brought up before also. You want to contain departments which are 9 to 5. I'm just using 9 to 5 as a loose term, but 12 hours operation, and the departments which are 24 hours operation, segregated in certain zones. It helps you contain for security reasons as an access control. It helps you contain for services, so your HVAC electrical loads are contained there. You can shut them off after peak hours. So that design philosophy has to be taken care of also. Building services, which I think you have touched a lot on it. Building services is if I again lose English here, it's God for hospital. I mean, it is a live building. This is the only building which is live, I would say. It actually goes 3 notches up of a 5-star hotel. It breathes, and it breathes every day full time. So services become very, very critical, and actually can take, as Dr. Vivek said, a huge load of financial load of the building also. It can actually cost a lot of money, which you don't anticipate as in the building. You think building cost X, it actually may be X plus Y as already maintained. So I already mentioned. Sustainable design, I'll not touch that because we fully had a presentation on sustainable. That is where sustainable design becomes actually more critical. If I do my building right, only in architecture, I can save a huge chunk of electricity load. HVAC load, which is actually air conditioning load on a building, is pretty much 40% of the electrical load of a hospital, if not more. And it's a huge chunk. You think equipment is a heavy load? Yes, equipment is heavy load, like a CT or MRI, but it's decentralized. It's 1 or 2 in the whole hospital, or 3 in the hospital. Air conditioning is everywhere, especially in a corporate setup right now. It's everywhere. The loads are very heavy. So sustainability becomes a huge, huge task to be actually taken care in a hospital. I think your hospital has succeeded very, very nicely to address that in a full like a Swiss watch. I would say it's like a Swiss watch. You have contained that way. And the last point here is brownfield projects, which have localized issues. We do a lot of brownfield. If people don't understand the word brownfield, it basically means existing building renovation or existing shell we are renovating to make it a hospital. It has its own nuisance value of a serious nature. We just finished a hospital which was meant for a mall. We have to take care of the heights, as Dr. Vivek, we have to take care of the OT fits, my cath lab fits in those heights. The structure is compatible for a hospital system. The fire exit strategy for a hospital is different from a retail building. So in case of fire, a hospital works differently than a retail building. So we have to do all the due diligence, but more and more moving forward, providers and operators are actually liking brownfield projects because they get built faster. You don't have to go through sanctioning process to start, your legal doesn't start from the land acquisition, all that. So if it's an existing building of some sort, you can take 15 months, get into the building. So we are actually feeling, in our design philosophy, we are trying to integrate that also. Now come to the actual basics. I may repeat this again because these are the 3 players who run the hospital, right? I mean, this is the human involvement of a hospital. These 3 things make a hospital. And I apologize if I'm writing doctors at the last, but I just, I just wrote the patient and his family and the doctor and the sequence of that. If we can take care of their comfort and conveniences, I think the hospital is somewhere already successful. So I'm going to talk about patient care and comfort first. Patient room, I'm talking purely single patient room right now, inboard to outboard toilet issue, which is discussed before. We advise today that it should be all inboard toilets. I know services may be a little challenging, but the patient does get a full view, much larger daylight. I have been told by a lot of healthcare providers that it helps in non-clinical healing for a patient if the daylight scenario is much larger than normal. So I think we propose that in that. Interiors of the hospital should not look like a hospital. I think first thing is that. It should look like a hotel, not for money. You don't have to spend money. It should not be white and gray. It has to have warm colors. It should feel that I'm actually living in a hotel, 2-star, 3-star, 4-star, doesn't matter, but a room which is providing me some healthcare assistance. That's it. That is actually very critical. We actually did one hospital where we even had a slider on the medical gases. So if the patient doesn't need medical gases in the patient room, the slider was put, it was a painting. So he never saw the medical gases. So it felt like a hotel room. So for him, it was like a painting and his bed and a TV and a nice support couch next to him. So those things help, I think, the non-clinical healing of a patient, not the clinical healing. Acoustically sensitive interiors. If you ask me as a patient myself in certain scenarios, or my family, and as an architect, noise is the biggest nuisance for a patient and generates anxiety of a high nature. If I'm in a room and there are 3 things beeping, beep, 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 I have a drip, and that noise actually, I've been told again by healthcare providers, that raises BP to 5 to 10% because of the anxiety generated by the noise in the room. So the room has to be acoustically sensitive, which absorbs as much as medical equipment noise created by whatever you're hooked up to. So we are preaching that on the wall paneling. Some of the ceilings also are doing that, so we're preaching that. Again, I'm repeating this wayfinding because the convenient the wayfinding, the patient is much, much easily absorbed to the hospital system. Nobody walks into a hospital because he's grabbing a coffee or having lunch with a friend. He is already anxious when he's walking into the door. So the more easier you make his life, he or she is actually feeling comfortable doing that. We recently, very serious discussion with multiple providers has been wellness and illness segregation. There are 2 types. Wellness basically, if I generalize, birthing centers, and illness, being illness, we all know, they should not mingle. They are total different mood points, they are total different usage. People are in different stress levels, one in a happy stress level, one in a sad stress level. If we can segregate and make them totally a different department within the multi-specialty hospital, it will help the situation. So we are preaching that idea right now in the design philosophy. Daycare, which I think, daycare is a stepchild. We all talk about OPD, we talk about IP or inpatient. We forget the daycare component. And to be very frank, daycare is the daycare patient is the patient which comes to the hospital much more than anybody else. The IP does his procedure, goes out. OP does his consulting, goes out. Daycare, like a chemotherapy or a dialysis, this is your constant patient. He's your fixed client, you like it or not. He's your fixed client. So we somewhere neglect the daycare facility philosophy in our design approaches. That I think has to be taken care of. Especially, it ties back to multiple departments. And I'll give an example of oncology, where if you have a line-egg bunker, it usually goes to -2 basement because it's a 6 feet concrete wall, which is the radiation oncology. And OPD goes to ground or first floor for oncology. Daycare goes to 2nd or 3rd floor depending on the stacking. You realize that the patient is actually struggling in 4 floors to do a treatment in a day. And so if we can solve these problems in our design criteria, it will help the daycare. Daycare is a critical component. It is probably in my mind the most critical component today, especially for some of the departments, oncology, nephrology. There. So if we take care of that, it helps us. Infection control. All these things tie back to each other. Infection control. If you don't mingle IP and OP, which is inpatient and outpatient, half the infection control problems are already solved. If you don't mingle them, you don't know who the person is coming. I've seen in a hospital, a newly born child has been traveling in the same lift as the outpatient support coming to see him. It's already not contagious. That place is not right for that space. So I think if we can take care of infection control in a serious way, it helps everybody. Family support, I think this is the second I used. Ample space in the room for the support. Support is helping the patient very seriously on the non-clinical healing. He's giving medicines. He can do a lot of things to the patient in a patient room. So he should have a reasonable space to sleep. He should be relaxed. He or she, relaxed and actually available to give comfort to the real patient. So if the support is not de-stressed, the patient is not being helped. So we have to take care of the support in that sense. Resting areas in the critical care units, like ICUs, you need to provide, I'm showing a sofa there, like a bed there. We need to provide, patient spaces for ICU patients. Decentralized food and beverage outlets. In a big, 1,000-bedded hospital, we can't have one cafeteria. We have to decentralize F&B where, all the people who are living there, can be fed reasonable food, like a food court situation here and there. It helps the situation. And I just wrote Wi-Fi connectivity. It just means whatever a hotel gives, we should try to give that as a support, because he could be working in the support has not taken a day off. He's living in the patient room with the patient and actually working online because he's working from home kind of approach. So all those facilities, if you can give on those lines, it will help the patient, help the patient support. And if I talk little branding-wise, the branding of hospital comes from support only. The patient is already in ICU, or patient is already in a bed. He or she is not saying, I like the hospital, I don't like the hospital. The support is telling, I like the hospital, I don't like the hospital. So the branding is built by the support. It's very critical for corporate hospitals to address the support. I think we lack there somewhere. I think we're trying to push that. Doctors and staff. I mean, this is, I wrote them last. I really apologize again. But, ample doctors' lounge and support spaces to be provided. Again, decentralized. If it's a huge hospital, we should decentralize it. You do not want doctors to walk half a kilometer to go to his lounge. You should have every space a lounge by itself. And the lounge should look like a lounge. It should not be a room with 2 sofas and a flat screen and a 32-inch. It should look like a lounge. If the doctor is de-stressed, this is already a better doctor to help the patient. So we preach that the lounge should no different. It should be no different than you go to American Express lounge in a international airport. For a doctor, he should look like that. He should have the facilities. And for the staff also, lockers, spaces, all those ancillary spaces for the support helps them work better, helps the patient care better. I think these are all connected. These are just, I think Dr. Vivek has talked, these are stacking diagrams of types of projects we do. OPDs and all at the bottom. Then this is opposite of Dr. Vivek said for a different reason. The beds are the yellow ones. They are before the OT and ICU. The only reason this is happening is we are trying to save the real estate for the service floor, which you mentioned, because we don't have the luxury. So the OTs have gone on the top floor and the ICU. So the air handling units for the OTs are sitting on the rooftop. It's an economical decision. It's not a medical planning decision, I would say that. This is actually this design philosophy probably matches the Kohinoor Hospital. It's actually H-shaped hospital. The core is in the middle. The core is already segregated into IP and OP, and service core is probably on the corners. So it is decentralized like that. This is what we are doing for a hospital in Delhi. This has a better expansion idea, but this approach, IP and OP never see each other. The core in the front is for all OP patient or outpatient. There's a backside full corridor which is supporting the inpatient and the services and support. So they don't even see each other. Once you're admitted, that patient cannot be seen till your family member who goes to the room. They don't never mingle with each other. Since today, we've been told, and we're trying to fast-track construction of a hospital because a lot of big players have come. There are a lot of investment in hospital system, and they want to build in a certain short time frame. So we are investigating. There are at least 2-3 structures or construction things we are using, which are a little different than typical construction. One is a waffle slab, which is it's not a concrete slab with beam. It is actually like a egg crate, and it helps. This is our teaching hospital we done in Bangalore. It helps to be flexible. See, hospital is done. I can move any wall anywhere, anytime if I need to, and I know my HVAC and everything going below is what the depth is. I have clear, less coordination for services, let's say then. And I can poke a hole anywhere I want if I move a toilet here and there, anywhere. So that helps in this. We have done this whole teaching hospital in this philosophy. Precast construction, which is the new, we are doing one hospital in precast, which is purely for the time factor and insulation and sustainable. We are doing a sandwich panel now in our hospital, which sandwich panel means it's a sandwich. It's a concrete, there's an insulation, there's a concrete again. So that panel actually creates the external skin with double glazing glass, which already mentioned. The thermal insulation of the building is much higher. You will save a huge chunk on HVAC loads. So, and the time to build this is probably for a corporate hospital 6 months less, if not more, to do in precast. So this is the systems which are using. I'll not go into that. This is the hospital images and some reference images of that. Steel construction. It has become now, in US, I always did steel hospitals. Only in India we do concrete because there's a different business model. But now in retrofitting, in brownfield, I'm doing a hospital in Gurgaon where it's already built hospital. I'm going vertically up as expansion. So we are doing a fully steel construction and a dry wall. I've not shown the imagery, dry wall, which means there's no wetness in the construction. There's no water. So no water means the partition walls are also dry wall, the external wall is also dry wall, which means less infection control, less nuisance value, faster construction, because it's a live hospital. So I think the construction technology is also being pushed because of the hospital needs as we're going forward. And that's what we are seeing. I think that's pretty much my light slide. I did good time. Thank you. Thank you.
Good afternoon, ladies and gentlemen. So far, I think a lot of speakers have talked about the design aspects of the building systems. But what we are going to cover now is a small fraction, but it's a critical fraction of the systems that go into the healthcare, which is an oxygen systems that we want to cover. And I also will take this opportunity to talk a little bit about Praxair, what we do, and what are the products we offer in the Medicare system. Here you see a couple of pictures. The first picture above is an example of an incident that happened recently at a hospital here in India. What you see there, the dark color, is a panel where there was a fire incident happened. There was a tubing which was carrying oxygen that went on fire, and it put a hole into the panel. And the bottom picture, what you see is the tubing which went around the panel. When the fire caught, it basically deflected and went and hit this. There was a glass, and it broke the glass there. So people, when they relate to oxygen, they don't understand some of the hazards that these oxygen systems have. What we are looking at here, one of the reasons we think might have happened is they might have selected a substandard material, or we call oxygen cleaning. I mean, many people have to understand the oxygen cleaning, if it is not done properly, and if you go to commission the system, it can cause fire. In our engineering terminology, we talk as a safety triangle. You have a spark. If there is an oxygen piping system, please make sure that people clean the system, purge the system before oxygen is put into these systems. Our request is anytime you have an oxygen system and you're commissioning the system, please ensure that these piping systems are purged with nitrogen or with air, and all the dirt is cleansed before you put oxygen. What happens if you don't do that? These particles, while traveling along with the oxygen, can cause a spark, and there, boom, you go, you get a fire. And it can be a serious issue. And also, whenever we have, when we talk about industrial gases, we are always big on safety. And safety, in Praxair, we talk safety first and then anything else. And even to the extent that we say safety is a condition of employment at Praxair. This is a good example where people have LMOs, liquid medical oxygen systems, at hospitals. You have to make sure if people are handling this or going near to these things, we don't want people. If we put systems in the hospitals, we manage it, everything. But if people go there, they can see cold burns happen if they're not using PPE, and if they don't understand the process well, and they go try to operate these things, just because it's an oxygen system, there can be serious consequences. Just a little bit about Praxair. We are a Fortune 250 company. We are about $12 billion in sales. We are about 26,000 employees. We operate in about 40 plus countries. And then we have a lot of patents. We have a huge technology center back in Buffalo, New York. And these are some of the markets we serve. Just to bring your attention, the key market we are looking at is the healthcare and medical. and we will talk about some of the products we offer in this industry. As I said, safety is in our DNA, and we believe at Praxair all accidents and incidents are preventable. And this is, we have to take this seriously. As we expand businesses, as we expand hospitals, we need to pay attention to these key areas, especially the oxygen systems. So what do we mean by safety, with respect to these oxygen systems? We think about safety right from design. I think speakers talked about, you take a look at the layouts, right? We think we better be involved when architects get involved in designing the buildings. Okay, you have designed the building, but also please include us right from the beginning so that we understand the space requirements. There are a lot of space requirements. There are a lot of engineering standards associated with this. And what we find often is people come to us, they put a building, and they come and say, boss, you have to come and put a liquid medical oxygen system. We go there, we see it. It's not practical, guys. It's not practical. And we walk away sometimes, and somebody goes and put the systems. That's okay. But there are serious hazards associated with these, and there are serious guidelines associated with that people have to understand these things. So we look at this in the design stage. I'll talk more about this. We also take care during fabrication and installation. What safety comes into play? What do we do? What are the different things you can look at when somebody is executing these projects? How do we take care of safety during commissioning? And how do we take care of these systems when we start up these systems? What is it involved? Training is a key area. How do we get it done? And then operations. How do we operate the systems? And how do we come back and support these facilities on a regular basis? Let us start with design. As I said, there are a lot of global standards. Some of the standards I was going through when the previous presenters were talking. One of the standards that we do is HTM, and then also PISO is an Indian standard. It's Petroleum and Explosive Safety Organization. These guys set the standards and guidelines for all the installations. And we are good at it, and we know what to do. So we request to use people like Praxair when it comes to the installations and not take decisions when it comes to layout. Please involve us so that we can do it as per the guidelines and we can get that value for you. And same thing with respect to other global codes. One of the codes that was mentioned previously was NFPA 99, right? There are several requirements. We understand the ASHRAE standards because we live and breathe engineering, guys. This is what we do a living, right? And also there are codes, say for vessels, there are codes like ASME Section 8 Division 1. There are several codes which we live day in and day out. So please involve us upfront so that we can bring value. And then as somebody said, when you work upfront, there's no repetition. You go and put a tank, and then you realize, boss, there's a problem, and then you have to go and fix it. It costs you more, much more than what you would have done if you have planned it properly. And then coming to reviews, what we have is, we call it as layout reviews. As per PISO guidelines, there are distance criteria. For example, when we go, we have even seen people have put these liquid medical oxygen tanks in confined spaces. Done. They don't understand if something leaks there, it's a confined space, people can get killed. They put in basements. That's not acceptable. And we have seen instances, people go and put tanks close to electrical systems. There's a transformer next to it. People go and put these tanks. That's a no-no. People go and put these systems next to diesel generators. That's a no-no. So these things have to be understood, and we do layout reviews during design. We bring a group of people who understand these standards within our organization, and we have even developed product line type of layout so that we can replicate very quickly. The next one is hazard reviews. When I talk about hazards, one is the layout, then we come to process safety hazards. When it is in the process, what are the valves that are used? What is the pressures we are using? How are these valves installed? Are the vents nearby? We look at all of these during the process reviews. Same thing is with material selection. If they go and select wrong material for oxygen systems, it can be bad. It can be very bad. Safety during fabrication and installation, couple of things we do. One is we go and make sure the suppliers are qualified properly. We have a selection criteria. We use the suppliers who understands oxygen systems. For example, we call it oxygen cleaning procedures. So if the guy doesn't understand oxygen cleaning procedure, he's out. Or we try to teach these guys and hold their hands. Same thing when it comes to copper bracing. There are certain ways to do these things, and we understand this, and we help these guys, and we take a lot of pain to make sure the right contractors are qualified. And then quality inspections. After you do installations, we go and verify whether these installations are done as per our standards or not. And then finally, we have people who are trained to come and do pre-startup reviews. What we do is we bring guys with an independent eye within the organization who are trained in multiple aspects to looking at these standards. They come, they review the entire pipeline system along with the standards, okay, along with the PISO guidelines. They verify whether this is as per the design or not before you push the button. Once you push the button, there's no way you can go back. So these guys also will review whether the permits are in place as per PISO guidelines or not, and then they will give clearance or thumbs up. We say, hey, these are startup items you need to do, and nobody can go and start this without completing those action items. And then comes commissioning and startup. People, as I said, signage is very important when it comes to handling chemical substances. And in the previous example, first example, there was no signage at all. So people have to use the signs. There's a reason for it. That's the first level of protection. At least they go and read it, right? And we now started even putting the signage in the local languages, which is very important. It's not just in English, but to put it in the local languages. And then we also do operating procedures review. We develop standard operating procedures, we review them, and we make sure that these are proven, and then we go and implement these on our systems. And then we go to these places where we put our systems and train customers and contractors on how to operate these systems. And this is very important. As you see, here is an example that where we went and completed this kind of training on SOPs and operating procedures. And please, these things are very important. It's not like any other chemicals, guys. This is very hazardous. People have to understand, and they should be trained properly. And then operations. In operations, we have the procedures. We make sure our drivers are trained. Whenever they go and decant the liquid, they wear the proper PPE. They follow the procedures. They know which valve should be opened first, how to decant it, and they're all trained. And we say nobody should go and touch those systems until they are trained, until they are properly trained by us. So all our drivers, all our people, they go regularly, visit these systems, and they are all trained. And then use of PPE, which is very important. People can take it lightly, and I can go examples whole day, how people have lost eyes, how people have lost hands without using the PPE. And then regular audits. What our drivers do is when they go, this is a very good practice that we have started at Praxair. Whenever they go and decant liquid into these tanks, they go and take pictures of the system, and they send that audit checklist. What we have noticed is sometimes you go and put a 1 KL tank, for example. After a couple of years, we find the way to that is actually obstructed, or some things have been put next to it. So we find all these things, and then we go back to the customer and say, boss, this is not good. We need to change these things. So this practice is very good, and it is helping us to go and educate the customers on a timely basis to prevent any big issues in the later stage. So safety is our number one priority. We do safe designs. We follow process for safe installations. Safe operations. We are well-trained people. We have well-trained people. and then safety training, and then safety audits. These are some of the healthcare products we have. Medical gases, portable oxygen, we call grab and go. We have oxygen concentrators. We even have cryogenic freezers for stem cells. And then these are the supply modes: medical oxygen tanks, cylinder manifolds we do, 1 KL tanks, mini bulk, and we also, this is the biggest one, we are the experts in medical gas pipeline systems. And we do entire portfolio of things. Here you see right from liquid, oxygen systems to, you have air systems, nitrous oxide. We take care as a turnkey solution. That's what we do for a living. And these are some of the client lists that we have been working, and we have more than 50 hospitals in India that we have been working so far. Thank you. Thank you for the time. This is the last one. Choose safety, and if you want to choose safety, come to Praxair, please. And we have a booth here. Take your time. Me and my colleagues will be there. We'll be happy to answer any questions anytime. Thank you.
Good afternoon, ladies and gentlemen. I'm going to talk about hand hygiene, which is probably a most neglected area in the personal life as well as in actually in the hospitals. Basically, Cleansa is a brand which is a very innovative hygiene and wellness brand. It's from the Resil Chemicals, and we make a lot of products and services based on sustainable technologies. I've just grouped the whole presentation into two parts. The first part basically addresses about hygiene, hand hygiene in the hospital scenario, and the second part is about hand sanitizers, how it is designed and how it can help in actually mitigating most of the challenges. Why hand hygiene? Basically, the hand's the most common vehicle for transmitting bacteria and germs and associated pathogens and causes diseases. And it's primarily required for both patients and to protect them from infections, further infections. The second thing is about protecting the healthcare workers who attend to these patients on regular basis. And basically, there is in hospitals, you are aware that the nosocomial infections are quite large, and the WHO addresses most of these issues by a lot of training and so on. So the solution is basically keeping hands clean, and the most important way to do it is by using sanitizers and cleaning. Typically, the best way to do it is by washing hands on a regular basis. But since it is not possible in the hospital kind of environment, people adopt to the sanitizers. And sanitizers, also the uses, it's not just a simple rub on the hand. As you go, you will understand that it's very important that the way to use the sanitizers is very important. And you know that sanitizers are becoming more and more popular. You find them in starting from coffee days to even the school kids nowadays, they take sanitizers to the schools. So I think it's a very important practice, and you will see that how it actually plays a vital role in the hospitals. The hospital-acquired infections, basically the nosocomial infections, are quite common in most of the hospital. People come with some infections, and probably they'll pick up a couple of more when they go back. So it's very important that people, when in hospital, and the workers, the healthcare workers, use sanitizers. But there are a lot of challenges people face, especially the healthcare workers face, because the most important reason is time. Most of them are quite busy, and so they forget to use hand sanitizers most of the time. And that leads to a lot of infection and spreading of infections. And you find that there are a lot of studies around this which WHO has published, and you find that 92% of the time the health worker uses basically probably a single press to just take the hand sanitizer and go forward. So there are a lot of challenges around how the sanitizer has to be designed to meet the hygiene aspect of the whole thing. And you find that many people don't use for reasons like skin irritations or use of gloves. They feel that if gloves is used, the hands are sanitized. And it basically boils down to the awareness of the whole thing. And in fact, the Indian practices, people don't shake hands, they say namaste in those old days. There are a lot of articles which says that people, it's like, I think a ban on shaking hands in the hospitals would sort of help in promoting hygiene and wellness. This is some of the data around WHO what been published. Basically, it's about even many places people use hand sanitizers, but not in a proper way, and the compliance of use is basically very low. And you find that most of the infections which are caused because of the lack of hand hygiene, primarily it's around the urinary tract infections, 30%, 15% in case of lower respiratory tract infections, 20% in surgical site infections, and 15% in case of blood infections. Basically, this leads to prolonged stay in hospitals, illness, and cost and disability, and it can even lead to death. So basically, if you really look at the challenges on how to use sanitizers, how to execute that, and make sure that the environment in the hospitals are safe. The first thing is the choice of the right sanitizer is very important. Second thing is involve the workers in choosing those sanitizers so that they know that the hand irritation, all those issues, mentally they're prepared to use the right ones. And find the barriers to usage. Many times you may not find those sanitizers available in the right places, the dispensers are not there in the right place. And this performance of hand hygiene, whenever they are in contact with the patients and body fluids, I think that's mandatory. Another way of building is that whenever there is hands are greasy or visible dirt is there, the only way to do it is to do a hand wash, which is there is no alternate solution to that. So I think then the post-wash you can use the sanitization. So I think the education is most important, and more than that, is there any monitoring around actually how much of hand sanitizer people use in the hospitals, especially the smaller nursing homes and the smaller hospitals? You find that the usage of hand sanitizer is very low. I think the awareness has to spread, and in large hospitals, the monitoring of how much actually is used in the and the trend of usage, that gives an indication how safe that area is. I think that has to on. The regulatory framework, basically CDC's guidelines, CDC 2007, which recommends hand sanitizers in various conditions, especially whenever in contact with body fluids, excretions, etc. All those, lists of things have been given. WHO is promoting hand hygiene through hand sanitization, and you find that, you need about minimum of 20 to 30 seconds to actually kill wet and, spread the whole, hygiene. Then Health Canada also recommends many of the specifications for efficacy of the hand sanitizers, which is about 3-log reduction, which is minimum required to meet the standards. And basically, clean hands saves lives. And there is actually May 5th is a day celebrated by WHO every year on hand sanitization, and I am sure that most hospitals will opt to it and spread the importance of hand hygiene. Hand sanitizers, basically the minimum requirement as per WHO is that it should have minimum 60% alcohols, and sometimes alcohol with other actives, probably for some residual action, which can help in going for, giving some efficacy, sustained efficacy. And if you look at the hand, basically it's about the surface area, total body surface area to the hand area is about 1%. So it's actually a small area overall, if you see, to apply and move forward and reduce 90% of the infections and diseases which can spread through hands. Coming to sanitizers, it's very important that the design of the sanitizers are chosen in the right way, because, for example, the dispensing format, you find that there are gels and foams. And the foam formats are typically preferred because it can quickly spread and it can give a very good coverage on the hand. And the right optimal dose of the formulation is basically one shot. So because most of the people use one shot and then quickly move forward because they don't have much of time. So the efficacy and the wetting and everything should be delivered within that one shot. And typical dose volume is 0.75 to 1.5 ml for foam, and 1.5 mil to 2.5 mil for gel. So basically, gels require higher volume for usage. So I think it's there the foam again scores. The wetting time and spreading time is very important. Basically, the formulation should be able to wet quickly the entire hand so that it basically neutralizes all the germs. And that's one of the key parameters to be watch out for. Coverage characteristics, basically the foam helps in covering faster and better. And the right contact time. The contact time of people can't just put hand sanitizer and then immediately get to work. It requires at least 30 seconds for it to go, spread, wet, and act. So it's important that people attend to that, give the right contact time. And the kill time of the actual active is important, because if you are putting synergistic actives, the kill time should be less than that 20-30 seconds so that it works faster. Quick dry time is another aspect. It should be balanced with the wet time, because if you put more of sanitizers, it is going to take more time to dry. So you have to wait for it to completely dry and then start acting on it. So if you put, on the contrary, if you use less sanitizers, your wetting and the efficacy is going to drop. So the right dose is important for use of hand sanitizers. Stickiness is another aspect. The feel, basically better the feel of the sanitizer, it basically promotes more use by the healthcare workers. And efficacy of the active ingredient, it's very key, and sometimes you can have synergistic active ingredients in that. And the most important is safety versus sustainability. You can't use very high quantity of hand sanitizers. At the same time, very low quantity, which again, basically, you balance both safety and sustainability. In all the things, basically execution, basically how much actually being used, tracking that, and the real-time data will help the hospital management to understand whether right quantity, right safety and quality of services is offered to the patients, so that they are protected. Hand sanitizers are basically, you need to actually, there are the ways of using it. It's described in these pictures. You will find them most of the time you find that the thumb is missed out whenever they apply hand sanitizer. Normally they put it and rub it, but they miss out the thumbs and the backside. So I think that's something to watch out in applying hand sanitizers. Testing, you will find most of the hand sanitizers are tested using standard methods, which is ASTME 2315, the kill method, and 2755. This is actually a residual action, and many times I think there is a trend to compensate the use of hand sanitizers with some residual action, because people don't use it because you need to apply. Actually, WHO says that there are you need to use about 5 times when you enter a patient room and till you come out to actually avoid complete contamination. I'm sure that not every hospital follows that. So obviously there is some sort of residual action probably might help in compensating those miss outs. And in summary, I would say that the hospital acquired infections, basically it causes serious disease burden, and also a cost to the whole the patient and the hospital healthcare systems. And appropriate hand hygiene, it's a simple task of cleaning the hands at the right time, in the right way, saves lives. The trend is to look out for residual efficacy so that it sort of helps in complementing the gaps. And most important, WHO recommends a lot of training. They have got training modules in their website, and you can see that there is a group awareness and continuous training program education to medium, small, and large hospitals, which can help in actually reducing the infections. So thank you so much for the SASH for giving an opportunity.